Hello everyone. Just wanted to show you how smooth the duty waveform is, which is the phase comparator output on pin 21 of IC701 on the main motor board of a Sony PS-X800 after a few modifications that I have done. That chip is the CX193. It's a 24-pin dip and it's a servo IC and part of the phase lock loop control system on the Sony PS-X800. Anyway, again, this was measured at the Duty Check test point, which is connected to pin 21, which is the phase comparator output. Anyway, what was done on this turntable, by the way, it is running right now. What was done on this is that I polished the main shaft spindle of the main Platter motor and changed the lubricant, and I also realigned the motor rotor magnet, which tends to be out of concentricity, a little bit of radial run out in a lot of these PS-X800s. So that was a job in and of itself, required removing the magnet. I won't get into all of the details on how that was done, and reattaching it with new adhesive, realigning it, and so forth. This is the best performance that I've seen on any PS-X800 that I've yet worked on. You can see how rock stable that waveform is at the Duty Check test point on the main motor board. I'll perturb the rotation a little bit with a mechanical drag impulse on it on the Platter, and you can check out its recovery characteristics and damping of the servo system. Okay, leave it alone, and it's very, very stable. Very impressed with that. By the way, the frequency generating pickup head was also adjusted in this, and that gave me even smoother performance. So anyway, here's we're currently running at 33 1/3 RPM. Here's 45 RPM, and that's also stable too. I'll perturb the Platter rotation with a physical drag impulse. And back to 33. You can see how it recovers very quickly when changing speed. It's very, very nice performance. Now I want to try one other thing here. I'm going to increase the rotational inertia by placing a additional thick black rubber mat on the Platter, and we're going to redo the test. Okay, so that's with an additional rubber mat on there that's it's about the same thickness as the original mat, so I don't know what that weighs, probably a pound or so. And I'm going to do the same mechanical impulse test on the side to periodically create some transient drag characteristics. And you can see its output from the phase comparator pin 21 is a little different. Seems to take longer to damp out, so its decay time, servo decay time, is a little longer with the extra mass. But it's also quite stable too. Okay. Alright, that's about all I want to show at this point. Hope you enjoyed the video. Thanks.